So Jeff is business development engineer at Spirent. He works with a lot of he works with automotive, their automotive segment.
Yes.
So we're going to have a quick chat here about automotive. I know you guys have heard a lot about automotive today, and there's a good reason for that. And that is a lot of the things I think that are being developed and researched and put through their paces in automotive. I think ultimately you're going to see some of that trickle down to other parts of the IoT testing ecosystem. So Jeff, tell us a little bit about what you do. We'll start there.
All right. So thanks for having me. I will start with that. So I've been in the industry about 18 years working in automotive in Detroit, Michigan, and currently working with Spirent and in the business development role, working with automotive OEMs and tier ones, and trying to understand what is the best approach that they need to do for testing these new technologies in vehicles. So with the advancement of all these new sensor suites, Ethernet is becoming very popular in a vehicle for radar, LiDAR signals, ultrasonic signals, and camera data. There's also a big explosion in data connectivity-wise in the vehicle, trying to get high precision centimeter level maps, and also getting some situational awareness information outside of the vehicle up into the cloud, so other autonomous vehicle fleets can actually use that information when they're trying to drive around a populated city or area where they can utilize that information, where every vehicle does not have to remap intersections or traffic signs. So working with customers to test and develop those new interfaces and technologies.
So what would you say are the areas that are most of interest when it comes to automotive test these days? You know, there's a lot of momentum in connected car. People are trying to do a lot of different things. What do you see as the big areas of development?
So a lot of that development, a lot of sensor fusion.
Okay.
So getting a situational awareness around the vehicle as it pertains to many different sensing technologies. The key to autonomous driving will not be just one sensor suite. You have to mix all of these sensing technologies together to give you a reliable and repeatable and a safe driving environment. Take, for instance, the camera-based system is only so good. Right now, if I was a camera-based system and these lights were in my face, it would be very difficult to get a good exposure and process the camera information to detect where the lanes are on the road. So then you would be able to switch over to a radar type system or a LiDAR type system, say in the rain or in the snow environments. So being able to mix all of that information together, so processing that data takes some time, and being able to get that processed data up into the cloud so other vehicles can actually download it and get that information out there so they can have a better autonomous driving experience.
You mentioned data. So let's talk a little bit about the amount of data that we're talking here, because I think that's one of the things that, you know, when you think about amount of data, when you think about implications for mobile networks, implications for even, you know, possibly Wi-Fi networks, if you're talking, you know, downloads at the end of the day, you know, from a vehicle, you know, but also processing that has implications for, and, you know, security and privacy too.
That's a lot.
Yes, sorry.
We'll start with the data, and then I'll try to transverse down to the security aspects. Okay. But from the data, there's so much information that's out there available. You know, thinking about things like trying to position your vehicle for autonomous driving, people think that you can just get civilian GPS data and use that for autonomous driving, but they neglect the fact that civilian GPS has right around a meter to 1.5 meters accuracy. So you can't rely just on this GPS data. You need other sensor suites. This is part of that sensor fusion that I'm talking about. And also other companies that are developing mapping technologies to give you centimeter accurate maps. You know, everybody jumps on their Google Maps on their phone and thinks that, oh, this is great, but there's a lot of algorithms and software in the background snapping you to the actual road. I think we've all probably experienced your navigation thinking that you're on a road sidestep away from where you actually are, and then your navigation has to recalculate. So there's a lot of that data can be better represented if you have better maps, more accurate maps. And then when we talk about security, security is just a huge aspect of autonomous driving because you're literally barreling down the road in a missile, and you want to ensure that your vehicle cannot be taken over or affected by other adverse conditions on the road. Either it's on purpose or not on purpose. Really, somebody maliciously trying to attack a vehicle. So security is obviously a big aspect. We're working with companies looking at sending security keys in a vehicle, say over Wi-Fi, and part of a key over Wi-Fi and part of a key over a copper interface. So it makes it a little bit harder to reverse engineer a system like this and get access to a vehicle.
Great. So one of the things that I think is interesting about the connected car as sort of a test case for IoT is that you really have multiple technologies. You have cellular, in some cases more than one cellular system, for the telematics, for the infotainment. You might have a Wi-Fi front end for something like the infotainment system. You've got Bluetooth. You've got maybe NFC for your door locks. Yep. You have a lot of different wireless systems, and then we're also thinking ahead to things like DSRC. Yes. And putting all of those in a vehicle is maybe a little bit of a different proposition than putting them in a handset or a module. Yep. But talk a little bit about some of the challenges there for integrating all those different kind of technologies.
Yes. So I'll touch base on, I guess, a few of them. So the vehicle-to-vehicle communication is a very low latency interface that vehicles will use to communicate with each other. So that's obviously one interface operating at the 5.9 frequency spectrum, gigahertz.
Yeah, that's the DSRC.
Yep,
right?
that's the DSRC.
Dedicated short-range communication.
Dedicated short-range communication. So it takes out all of the negotiation and latency that a typical Wi-Fi interface would have, or say a cellular interface. So that's just one aspect that we're trying to use to improve fuel economy, so doing things like cooperative adaptive cruise control, where nobody wants to be stuck on a highway in congestion. If we can have the traffic light a mile away, the old math problems, if you're traveling 60 miles an hour, how long will it take to get to that traffic light? If we can get that information out of the traffic light and know when it's about to turn red, we can slow everybody down and cause better flow. I mean, we've seen that in today's presentation from MIT. That was great. So that's on the V2V or V2X interface. But when we start talking about cellular, we did some security research on a couple of OEM vehicles, and we found in one vehicle there was 3 to 4 different cellular modems in that one vehicle. So just think about the cost savings now. You've got a cellular modem for a concierge service. You've got a cellular modem for your infotainment. You've got a cellular modem for possibly theft or things like that. So we were able to find and identify these 3 cellular modems in a vehicle. So doing virtual testing, we've got a product called Virtual Test Track that you're able to check different handoff conditions and different border conditions. That's also something that customers are also looking at to be able to reduce the drive testing, the actual live drive testing.
And what about some of the unlicensed stuff? The Wi-Fi, the Bluetooth,
Yes. So everybody, in one of the morning discussions, a lot of OEMs are representing the new millenniums, right? And people are looking at Wi-Fi technology in a vehicle. So now we're spending almost more time in a vehicle these days than than at home a lot of times, and being able to get ride-sharing applications and being able to work in a vehicle is going to become very critical, coming in the future when you start doing some ride sharing. I was talking to a recent executive in Detroit, and he was taking a ride sharing car to an event because he could do some work in the vehicle. So it was 45 minutes to an hour drive each way, and that's 2 hours that he gained that he's able to do emails and work on presentations that he would not have had if he was driving behind the wheel. So Wi-Fi connectivity will become more important. So testing all these interfaces and checking the latency and throughput really starts becoming more critical now. So not only will your cellular interface be downloading high precision maps, it'll also be trying to connect you to the cloud and get your Wi-Fi interface in the vehicle.
Let's talk for a second about internal versus external vehicle systems, because I think this is kind of an interesting area. We think about the vehicle communicating to the rest of a network, but the vehicle also has an internal network that is getting increasingly complicated.
Yes.
I know you guys, if I remember correctly, Spirent, is focused pretty heavily on automotive Ethernet, because that's something that's coming to vehicle systems. There are concerns about vulnerability there, but there are also I think a lot to be gained. I know one of the demos that I heard about from Mobile World Congress was robotic arms that they were hooked up to a 5G demo system, and instead of wired connections, the latency was such that you could move them in concert together, and you had that kind of wireless connectivity for a system internally, not necessarily connecting to any external network. So what do you think are some of the opportunities, for internal communications for the vehicle as well?
So that's a great question. So with higher and higher bandwidth sensing technology that would be required, say, for autonomous driving, that's driving the need to change and upheave the architecture of a vehicle. In the vehicle right now, there's something called a controller area network. It's called a CAN bus, and that bus is overloaded. I don't want to say it's overloaded right now. Every vehicle manufacturer out in that parking lot is probably above the standard 35% utilization that was put in place 15 years ago. So the actual architecture, the backbone of a vehicle needs to change, and we need to get a higher bandwidth architecture, and OEMs do not want to look at proprietary networks. They want standard open technologies like Ethernet. So Spirent is part of the IEEE and SAE organizations and the Ethernet Open Alliance organizations, and we're working to develop conformance test suites and performance test suites to allow customers to check these networks in a vehicle, to be able to check the sensor data throughput and sensor data flow before they go out and do some expensive drive testing. And a lot of times you don't have the luxury of having 5 or 6 vehicles in a fleet to try to test all this communication, so you have to do this work on the bench.
So I want to ask one last question, and that is, what lessons do you think, lessons and or technology, do you think will carry over from the automotive space to the rest of IoT? I mean, I hear you saying things, mission critical security could very well be one. The ability to integrate, multiple types of technology, not just multiple, but, half a dozen or more. What are your thoughts on things that automotive will eventually teach the rest of IoT?
Oh, that's a good one. The vehicle, I guess IoT can learn a lot about vehicle development and technology, because it's definitely a different animal. We're talking about a consumer product, like an IoT consumer product, versus an automotive product where we don't have the luxury to restart in the middle. I mean, I've worked on projects where I've done testing on vehicles, and I've shifted the car in neutral, shut it off, and turned it back on. And it damn well better turn back on, or we've got a problem. In your IoT device, if you lock up, you can always pull the battery, turn it on, or do something like that. In a vehicle, we don't always have that luxury. So safety testing, reliability, regression testing are all lessons that you can take from automotive and bring into the IoT world. I think that's a good area to focus on.
Okay,
Yeah.
great. Well, Jeff, thank you so much. We are going to move on to, I think, multi-fire. So thank you very much.
All right, thank you very much.